Good morning. This is a video presentation for Project 2. The topic is relationship between education and adolescent fertility rate. My name is Taiwan Jun. The matrix is A19 AC0207. Student of Probability Statistic Analysis from Year 1. So, back in the old days, female have to childbearing in early age due to able to give birth healthier baby. If you remember our grandmother, they will marry at very young age, such as 20, and those who are married at age 30, which is normal in these days, they will consider very late of marriage. Early childbearing can cause female to take responsible earlier than her peer, which she has to take responsible of her baby instead of going to study or going to work. The mother has to face more risk in childbearing than compared to those who have been childbearing after her 20s. So, developing countries such as Africa have an average of 114 per 1,000 adolescent fertility rate, which is 10% of its data. It is a very high percentage. So, the data used in this study, we're going to use the data of Singapore because it's a developed country that famous in low crime, low corruption, and high standard of education. We're going to use the variable of adolescent fertility rate between age 15 to 19 per 1,000. And we're going to use another female secondary education enrollment rate, and so is the male secondary education enrollment rate. We're going to use also the government expenditure on education on this study too. The data source of this study is the Singapore open source data and the World Bank data, which is the source is very reliable. Next, for the tests that we're going to do for this study, we're going to have 4 tests. The first is one sample test, which is a test on claim value and value observed. And the next is chi-square test on dependency, which is a test on the dependency of variable. And then we're going to do the correlation test, which is test on the coefficient of correlation and the significance of correlation. And last but not least, we're going to do regression test, which is test on the coefficient of determination and linear equation and the significance of linear relationship. Next, on the one sample test, we're going to test is the mean of adolescent fertility rate of Singapore is lower than the average adolescent fertility rate of the globe. Because Singapore is a developed country, it should have a lower adolescent fertility rate. The null hypothesis for this test is the mean is 47, which the 47 is the value that we get from the WHO, which is the average adolescent fertility rate of the globe. The alternate hypothesis is the mean is lower than 47. From the test, we get that the test statistic is negative 222.8, which is lower than the critical value negative 1.86. From the test, we reject the null hypothesis and conclude that Singapore has lower mean of adolescent fertility rate than average global adolescent fertility rate. On next test, we're going to do chi-square test. To test, this test is test on the female secondary education enrollment rate and male secondary education enrollment rate. A null hypothesis for this test is variables are independent. The alternate hypothesis is that variables are dependent. From the test in RStudio, we failed to reject the null hypothesis. We can conclude that the variables are independent. The figure that below is shown that the function of chi-square test from the RStudio. We get that the probability value is equal to 1, which is greater than our accuracy level, which is 0.05. So we are unable to reject the null hypothesis. Go on to the next test. We're going to test on the correlation. This correlation test is to test the linear correlation between female education enrollment rate and adolescent fertility rate. From the test, we reject the null hypothesis and conclude that there is linear correlation between the variables. From the figure on the right, This is a figure that created the graph created from the ggScatter function from RStudio, which is a function that created to plot the data of the variable and create the coefficient of correlation of the variables. The coefficient of correlation of the variable is negative 0.83, which a negative sign indicates that when the female education enrollment rate increase, the adolescent fertility rate per 1000 will decrease. And when the value of 0.83 is lower than negative 0.8, which if you look at the figure below, this is a very strong relationship. And next, we're going to do the regression test. In this test, we're going to use the LM function from RStudio and do significance test on a linear relationship. From RStudio, we get the linear equation of the relation between the variables is y equal to negative 0.2569x plus 30.1786. We successfully reject the null hypothesis and conclude that there is linear relationship between female secondary education enrollment rate and adolescent fertility rate. The coefficient of determination that we get is 0.69, which means that 69% of variation of y is explained by the variation of x. And next, this is an additional study. We test on the effect of government expenditure on education to female education enrollment rate. From the figure beside, it is the same figure that created from the function ggScatter from RStudio that for the plotting and get the coefficient of correlation. The coefficient of correlation that we get in this test is 0.86, which means that the positive sign, which means that when the expenditure of government on education increase, the female education enrollment rate will also increase. The 0.89 value is greater than 0.8, which also means that this is a very strong relationship. And then we get the linear equation of these variables is y equal to 1.416 times 10 power of negative 6 plus 83.38. From the significant test, we prove that there is linear relationship between variable axes. And then we get that the coefficient of determination in this test is 0.78, which means that 78% of variation of y is explained by the variation of x. In the conclusion, we can conclude that the increase of female education enrollment rate will decrease the adolescent fertility rate. So, how do we increase the female education enrollment rate? The government should increase the expenditure in education so that the female can have a wider opportunity in their study and so in their work, instead of they had to take care of their child in their early age, such as 20, and unable to study in higher education, such as university. This is my video presentation for project 2. Thank you for listening.